Let's try solving a few more systems of equations using the elimination method. However, the problems that we look at today aren't necessarily going to be a one-step elimination process. We might have to do a little extra work to get those systems to where we can actually eliminate them. So we'll start by looking at x minus y equals 5 and 3x plus 2y equals 15. Now remember from the last lesson, when we use elimination, we're literally trying to cancel out one of those variables. And in order to do that, we said that you have to have one of the variables having the same coefficient but different signs on that coefficient. So if I look here at the x's, I realize that I have a 3 on the bottom equation and a 1 on the top equation. They're not the same number, nor do they have different signs. When I take a look at the y's, I see that I have a 2 on the bottom and a negative 1 on the top. So I do have different signs, but the coefficient is not the same digit. So what we can do is we can use a little bit of multiplication to help us get these equations to where one of the coefficients would cancel out. So I realize that I have a positive 2 on the bottom and I have a negative 1 on the top. So if we multiply the whole top equation by 2, that would make the coefficient with the y term become a negative 2, which should help us in canceling out the y terms. So I'm going to multiply this 2 by everything on the top, so that's going to leave me with 2x minus 2y equals 10, and on the bottom it's going to be 3x plus 2y equals 15. I'm not going to change that equation at all. So now I can see that when I go ahead and make this a giant addition problem, I've got 2x plus 3x, which is 5x, and I've got 2y, negative 2y plus 2y, which is going to cancel out and give me 0, and then 10 plus 15 is going to give me 25. A one step after that would be to divide both sides by 5, so x comes out to be equal to 5. Now to figure out my y term, I'm just going to select either one of the two original equations. I'm going to go ahead and just go with the top one, so x minus y equals 5. I'm going to substitute my 5 back in the place of y. So it's going to be 5 minus y equals 5. So when I subtract 5 from both sides, I'm going to get negative y equals 0. And of course, you know we have to divide everything by negative 1, but 0 divided by any number is 0. So that leaves me with a final solution of 5, 0. So just to recap what we just did, I realized that we did not have the same coefficient on either one of our variables, so we were able to use multiplication to get those terms to be the same, and then it becomes the same type of elimination that we've looked at in the past where we're just using simple addition. Let's look at another example. This time we'll start with 2x plus 3y equals 0 and 3x plus y equals 7. Now when you're using elimination, you really have your option of what coefficient you'd like to eliminate. So if you'd like to eliminate the x's in this problem, you would have to realize that you have a 2 and a 3 as your coefficients. So if I think about their least common multiple, that number is a 6, so I'd have to make the top number become a 6 and the bottom number become a negative 6, or I could make the top become negative 6 and the bottom become positive 6. However, I look here and I see that I have a 3 and I have a 1, and anytime you have a 1, it makes life a little bit easier because you should only have to multiply one of your equations. Now, if I just multiply this bottom equation by 3, what's going to happen is I'm going to end up with a positive 3 in front of my y, and I really should have a negative 3. So I'm going to make this 3 negative. So when I multiply, I'm going to leave the top equation the same this time, so 2x plus 3y equals 0. And the bottom one's going to become negative 9x minus 3y equals negative 21. Again, let's make it a giant addition problem. So I'm going to end up with negative 7, 3y minus 3y are going to cancel, and 0 minus 21 is negative 21. Divide both sides by negative 7, x equals positive 3. So I take my positive 3, I'm going to pick one of my two equations there. I'm just going to go ahead and go with the top one again. So that's going to be 2 times 3 plus 3y equals 0. So that's 6 plus 3y equals 0. Subtracting 6 gives us 3y equals negative 6. And when I divide, I get y equals negative 2. So that will leave me with a final solution of 3 comma negative 2. And of course the check step works for this just like it works for the other elimination problems that we looked at. Alright, I have one more example for you. So let's start with this time with 5x minus 10y equals 15. And let's go with the bottom, 3x minus 2y equals 3. So again, you have your choice at what variable you'd like to eliminate. If you wanted to eliminate the x's, you'd have to think about their least common multiple between 5 and 3, and that's 15. So you'd have to make one of them be a positive 15 and one of them be a negative 15. If I look at 10 and 2, actually negative 10 and negative 2, I realize that my least common multiple between those two numbers is actually a 10, which means the top number would not have to change at all. So I could multiply the bottom equation by a negative 5. Now you might ask, why did I choose negative 5? Well, because I know that these signs currently are the same, and I need one of them to change. So I need to multiply by negative. Anytime you need a sign to change, you multiply by a negative. So on top, I'm going to get 5x minus 10y equals 15. And on bottom this time, I'm going to get negative 15x plus 10y equals negative 15. Again, your addition problem, it's going to give me negative 10x. These are going to cancel out, and this is going to give me 0. So 0 divided by any number is 0. So take your 0, substitute it back into one of your problems. I'm going to go with the top one. So 5 times 0 is 0. I don't even need to use it anymore. So I'm left with negative 10y equals 15. Dividing both sides by negative 10, y is equal to negative 3 over 2. And it's okay that we got a fraction answer there, not a big deal. So my final answer will be 0, comma, negative 3/2. So there's your second type of elimination problems where you realize that you've got to use a little bit of multiplication to make one of the equations have a different coefficient. And then once you have different coefficients, or I'm sorry, the same coefficient with different signs, then you can go ahead and do your typical elimination problem. So again, I'd like to have you hop on over to Edmodo, do your couple practice questions there, and we will check those at the beginning of class tomorrow. Thanks a lot.